The construction of this motor is actually very nice. I mean, it is so nice, it makes other motors look outdated. It does have 2 sensor ports. It does come with a little dust cover, so top or bottom. It's just 2 little screws for the timing, and the timing belt is very smooth because it's a separate piece from the actual part that holds the rotor in, compared to, for example, the Trinity. The Trinity, the timing is the same back plate that holds everything together. Here it does not. Now this one still uses those 3 long screws to hold everything together, but it works. They will stretch. I mean, screws stretch, that's just normal. So I probably would not use, for example, other material screws. Just keep that in mind. But this one, if you compare the way this motor looks to a Trinity or a Phantom, it does make them look old. This one looks very modern as far as design. I do like the fact that the laminations are exposed, and that front end belt, just the increased surface area, I think should make a massive difference in cooling. Now, as of now, 21.5, I am not going to be running this next season. I'll probably end up running this in my TC for 21.5 instead of 17.5, but we'll see once we get there. The timing spread is pretty good. It's not bad. The KVs are actually good, especially here at 4 amps. That's the best one to compare to the Trinity Xfactor. At 4 amps, both of them surprisingly do the same KVs. The difference is the degrees. This one does the same KVs, same amps at 2 degrees less. So that should be a factor that helps Hobbywing when it comes to dissipating heat. It matches the KVs at lower timing because it's a revving motor, which is one of the reasons why I'm interested in using it. But let me show you the data table so you can actually compare them, how they do on paper. This is the data for the 21.5 motors that I've tested. I am going to delete this, but you can pause if you want to see how the Trinity Xfactor performed with the 1150 rotor, which is the 11.5. Now that's a high RPM rotor. It's actually, it's pretty smooth. Less torque, but it's pretty smooth. You have to compensate with gearing, which is something to keep in mind. High KVs, generally, you just gear lower. But we'll see how it does. Usually, it's a temperature game. That's what it generally turns out to be. And the higher the timing, the higher the temperature sometimes, which is one of the things that I do like about these Hobbywing motors in comparison. So we're going to go ahead and look at this 4 amp category. And the reason why is because I managed to get 4 amps as well. And then we can also compare the 3 to 3.1. That one's close enough. But at 4 amps, the Hobbywing, it has approximately 2,591 kVs, 2,445. So we have over 100 kV more. Now here, luckily we have the same voltage, 7.6, 7.6, so we can actually compare RPM. And RPM, we're looking at 8,000 RPM more, approximately, just based on that. So 1,000 RPM, that is a significant difference. And keep in mind, that's at this voltage. This isn't at fully charged. So if your system is delivering more voltage, then you would be getting more RPM. Now, if we look at 3.13, they are close enough, 2533 versus 2390. Now, the RPM difference here is just over 1,000, and you're slightly lower amps. Now here we're in the danger zone, and what I mean by that is you run the risk of overheating your motor, but even here, there is quite a bit of a difference. Now, something I really want to point out is if we look at the 4. So if we look at the 4, this is really what I want to look at. The timing is actually pretty close. It's just 2 degree difference, which is different. And the reason why I say that is if you watch my other videos that I will have with my 17.5, with the Hobbywing 17.5 and the 13.5, generally those motors are pulling similar amps at 4 or 5 degrees less, or similar kVs with less timing. But here they're actually pretty close. So here 43, 41. So this is a 3.1. So here's where you notice, see there's that 2 degree difference. Here the degrees of timing are about the same, but we've already exceeded, well, you need to have a very good fan with high flow, a very high efficient fan in order to keep this cool for an entire race. But here we go. You can see the kV difference between the two. So would I select the Hobbywing? I think it's a very good option. I like the Trinity. I'm actually running this motor in my TC. But next season I may try the Hobbywing, I like the numbers. The numbers look very, very good. Now, compared to USGT, it doesn't compare. This is supposed to be a stock class. This is actually very, very slow. I ran this once in a mini, rear-wheel drive mini. I actually did like the way it drove, but everybody else was using regular 21.5 motors with timing to boot, so there was no competing. But here we go. So Traxxas Team Powers. All right. So if we look at this 5.2, so 2414, 20. Okay, so less kV. Now here's the thing. This one has less kV, but less power, runs less. Sometimes you get a stronger motor. Not really. The can is massive. So these are going to cool better. Especially the Hobbywing. The construction is very, very nice. Very nice construction. The way that they did the front of the end bell, just the exposed laminations, air would blow directly on there. Although with the Trinity, those little aluminum ribs that it has, those could work as heat sinks as well. So only testing it would help. But if you look at the front end of the bell, that's what I think will actually make the difference. But you can pause and compare the data, get the data here. So I do think out of these motors, it would really be between the Trinity and the Hobbywing. I would be stuck between the two. Luckily, I have both motors, so that'll work. It's just a matter of soldering one off, soldering the other one on. Now, here's the data. I'm now going to talk about the construction of the Hobbywing. Now, when I'm talking about the construction of the Hobbywing, the motor that I'm using is actually a 13.5, and the reason why is because I have a 13.5 Trinity that's not installed, so it's just easier to compare the two. Now, the rotors are different between this one and the 13.5. The 13.5 and the 17.5 have the same rotor. This one has a slightly different rotor. But the shimming is the same, which is wonderful. And what I mean by the same, I mean between the Hobbywing motors, which is, I think, way better than the Trinity from that perspective. So maybe that helps out a little. The other thing, too, is just in general, the spread. This one is actually very good. But compared to some other motors, this is not bad. This is actually not bad. This one was not bad either, but there are some motors out there with a huge spread in timing. Actually, the Turnigy Traxxas is actually pretty good when it comes to timing as well. This one was horrible. But anyway, keep that in mind. Well, let me go over just some basic conversation about the construction. These Hobbywing motors are actually constructed very nicely. So I took one apart. These little tabs just go in here. This is where the screws go, and they screw on right in here. So that is one of the differences. The Hobbywing's still using these long screws. Just be careful, they can stretch. But the construction, this is just such a beautiful piece. This is flat compared to, for example, I did not take this one, do not unsolder it, but this one's not flat. I really don't know if it makes a difference or not, but you can see the distance, the little waves there. As you can see, there is material covering the laminations. That's aluminum. Is that going to affect it much? I'm not really sure, but I do like the material in the end bell. This looks like it will work as a heat sink compared to this one.
just offers more surface area here compared to this. So I'm thinking the Hobbywing will probably be better at cooling, just running cooler, which is very nice. This goes in here, all the turns, everything looks very well made. I'm actually quite impressed. I do like the Hobbywing ESCs. I actually really like the Hobbywing ESCs. One of the things that I was surprised though is I removed the rotor. This is the only shim. It's just this. There's nothing here in the back. This is actually quite small compared to some of the other motors. For example, Trinity motors actually have, let's see, I have a rotor. That's not the stock rotor though. Here it is. It's right over here. So this is a Trinity rotor. And a Trinity rotor, so you see the shims that it comes with. So there's 4 little brass shims. The amount of shimming is actually quite large. Now I'm not going to put these close, but you can see there's a difference in diameter. I'm trying not to get these close because they're magnets. It appears to be a difference, but there's a massive difference in length in this part here. So let me go ahead and all right, so this is the Trinity. So it's about 3 millimeter. Now this other section over here is about a 4.78. 1225. Now I really shouldn't measure this because it's not the same. Well, no, actually this comes in the 13.5. I don't remember what comes in the 13.5, but since I opened the 13.5, that's why. So this is supposed to be 3 millimeters. All right, so that's normal. Now, the brass bushing is 429, and this is approximately 24.5, this length. Now the entire thing, I'm curious, right here, magnetic part is 28. Let's see, that sits perfectly. All right, so 27.8 roughly. And overall, 62.85. So that is interesting. But like I said, the main thing is there's no more, this one doesn't use shims for the rear part of the motor, which is wonderful. And then the shim in the front is small, very small. Let's see, I completely missed. All right, so I'll put this one away. Now I'm gonna look at the Hobbywing. So the Hobbywing, here's the shim. Shim is very small. This is maybe 2 millimeters at most, maybe 1.5. Oh, it's not even a millimeter. I was way off. So it's less than a millimeter for the shim. This whole area in front, well, I guess if I measure from the front of that, all right, it's about 20-25. Now, let's go ahead and put the shim back on just so I don't lose it. Now let's see, this rotor, this is a 12.5 rotor. All right, 12.5. Let's see. All right, so that was a good comparison with the other one. Although the other one's a 12.3. But the magnet with this part is 27.98. If I get rid of this, okay, so just that part is about 25.45, somewhere around there. Now it's supposed to be a, it says 12.5, but it looks like a 12.24. So it's the same diameter as that other one. So this was actually a good comparison as far as measurements. So that's good. So why does it say 12.5? Maybe it's 12.5 here at the collar. Oh, I think I did an overall. Oops. Let me zero this out. Oops. Zeroed out. 5587. 5587. But these things are nice. Now, if we look at the sensor board, they are, I don't want to put the calipers here. So they're about the same depth. This one looks shorter than this one. That's just because of this end plate down here. So if I were to go something like this, this one's actually shorter. Let's see, that's probably, let's see if I can get them in the camera. So there isn't much difference, but that's what we have. So those are some of the differences. Now this one, it's just these two screws you loosen, and then this just spins really easily. This one, some of them are a little tougher than others to actually rotate, which not a big deal. You can just use pliers, set them in here and turn them. I actually do like the Hobbywig construction. Now, like I said, it does use these screws versus this just uses the screws in the M-bell. So this is one of the differences. If you look at this construction versus this construction, you can see the difference with the laminations. And let's see. So you have 35.8, and just need to measure apart with that tape. There we go. 35.9, almost 36. But part of the difference is going to come from this. You have about 1.70 millimeters in thickness here. But the main thing, like I said, only testing will tell. But the main thing is that larger surface area on the front, which I find to be important because usually the cooling fan goes off to the side. Some people mount it in the rear, but not really in the front. So that increased surface area will help with heat dissipation. It should, and that's quite a lot of material. So most of this material went to the front of the motor where everything can dissipate. So if you have, for example, I have a shroud, it'll blow air right through these, which will be fabulous. Now, as far as sensors are concerned, this one only has one sensor connection. This one has two. There's one on the bottom and there's one on the top. It does come with a little rubber piece I removed, but you can, if you're using the bottom, place it on the top. It's a little dust cover, or vice versa.
Oh, my hair! My tongue! My rod!